So, sorry for inconvenience. Well, we will discuss in fact the addition formulas, and as an application we will give certain examples. At the same time, the corresponding formulas for subtraction will also be discussed. So, after reading this text, in fact you will be capable enough to understand the following 6 addition formulas. The number 1, the first 2 addition formulas, namely cos of alpha plus beta. At the same time we will discuss cos of alpha plus minus of beta, that is same thing, cos of alpha minus beta. And the second 2 addition formula, they will be sin of alpha plus minus beta, and derivations of the 2 formulas for tan of alpha plus beta as well as tan of alpha minus beta, and finally we shall discuss some examples by using these 6 formulae. So, first of all we will discuss the cosine of the sum and difference of 2 angles. Well, as I gave you in the beginning as a remark, there was a separate lecture for finding out the formula for the differences, but at the same time while deriving the formula for alpha plus beta or cos alpha plus beta or sin alpha plus beta or tan alpha plus beta, I am giving you the corresponding formula for cos of alpha minus beta. So, for the completeness of this I will be continuing in next lecture also, so that the 2 lectures they will be of same nature. So, first of all we consider the formula that cos of alpha plus beta, where alpha and beta are the angles. Well, first of all as a remark, this is not equal to cos of alpha plus cos of beta. In fact, the value of this expression turns out to be cos alpha cos beta minus sin alpha sin beta. So, corresponding formula for cos of alpha minus beta, that can be obtained very easily replacing beta by minus beta, and that will turn out to be cos of alpha minus beta is equal to cos alpha cos beta plus sin alpha sin beta. And just for the sake of completeness, let me give you a simple proof of the first identity, namely the addition formula for cosine, that is cos of alpha plus beta is cos alpha cos beta minus sin alpha sin beta. So, this is a very simple geometrical proof. Let me draw a circle with radius 1 unit whose point P, that is mentioned over here by blue, that is blue color, that is P, the point is 1 0, because I am considering the circle of unit radius. Similarly, the Q point, because if I am choosing the alpha angle as shown in the picture and the hypotenuse in this case is 1. Therefore, if I consider the triangle which is mentioned in the picture, the points Q can be taken as x coordinate as cos alpha, y coordinate as sin alpha. Now, we extended this idea by drawing another angle, let us say beta. So, corresponding angle in the the last quadrant, not third, the fourth quadrant, that is minus of beta. So, as shown by arrow, the angle alpha, alpha minus beta and alpha plus beta all are mentioned in the picture very clearly. So, the corresponding coordinates of the point R, they will be, as in the case of Q, here also they will be cos of alpha plus beta, sin alpha plus beta and similarly the coordinates of the point S, they will be cos of minus beta, sine of minus beta. Now you use the distance formula and we find out the value. If you go through the figure which I have just shown you, then PR square, that is the formula of the geometry, distance between 2 points whose coordinates are x1 y1, x2 y2, then distance is given by this formula. So, cos of alpha plus beta minus 1 whole square plus sin square alpha plus beta. Now, using the formula a minus b whole square, this will be cos square of alpha plus beta minus 2 cos alpha plus beta plus 1 plus sin square alpha plus beta, and all of you know sin square theta plus cos square theta is equal to 1. So, using this identity we get PR square is equal to 2 minus 2 cos of alpha plus beta. Again we use the distance formula for the distance QS, and the distance QS will be square root of the right hand side. So, I am taking QS square, this is cos of alpha minus cos of minus beta whole square plus sin alpha minus sin of minus beta whole square. Once again I apply the formula a minus b whole square. So, this will be cos square alpha minus 2 cos alpha cos minus beta plus cos square minus beta. Now, the second bracket will be sin square alpha minus 2 sin alpha sin of minus beta plus sin square minus beta. And once again I use the same identity, sin square alpha plus cos square alpha is equal to 1 and sin square minus beta plus cos square minus beta is equal to 1. I get the value QS square is equal to 2 minus 2 cos alpha cos beta plus 2 sin alpha sin beta. Now, as from the picture itself, as I mentioned, you have the distance PR is same as QS. So, the two values or the two distances, namely PR square and QS square, we can equate them, and after equating these two values we get 2 minus 2 cos of alpha plus beta is equal to 2 minus 2 cos alpha cos beta plus 2 sin alpha sin beta. Now, subtract 2 from both the sides and dividing the expression throughout by minus 2, what we obtain is the following, that is cos of alpha plus beta is equal to cos alpha cos beta minus sin alpha sin beta. Now, this is the formula which I have derived, or I have given you a simple proof, that is purely geometrical proof, and with the help of this formula only, that is cos of alpha plus beta is cos alpha cos beta minus sin alpha sin beta. I will derive number of formulas using very trivial remarks regarding trigonometric functions. Now, one thing is very important that can be observed from this expression only, that is in the expression cos of alpha plus beta is there. So, plus sign is there, then right hand side is having minus sign, cos alpha cos beta minus sin alpha sin beta. Similarly, we can derive this formula simply merely replacing beta by minus beta, and all of you know that sin minus theta is minus sin theta, cos of minus theta is cos theta. So, using this relation, what we get, cos of alpha minus beta is cos alpha cos of minus beta, but cos minus beta is same thing as cos beta, and sin beta is same thing, sin beta is minus sin beta. So, on right hand side we will have the expression cos alpha cos beta plus sin alpha sin beta. So, the second formula is a trivial consequence of the formula which we obtained for cos of alpha plus beta. Next, the corresponding formula for the sine, that is sine of the sum and differences of two angles. Once again I am here giving you a remark, or I am giving you a comment, that basically in your scheduled lecture I was supposed to discuss the formula for the addition only or for the sum only, but as you have seen in the first case, the corresponding formula for the differences can also be obtained very easily by using the formulas for addition. So, next is sine of alpha minus beta is equal to sin alpha cos beta minus cos alpha sin beta. Now, here if you look it, then in left hand side it is alpha minus beta, and in the right hand side the sign is also minus. So, in the case of cos of alpha minus beta, which I just discussed, it was of plus sign, but in case of sin alpha minus beta or sin alpha plus beta, the signature on both the sides, means on left hand side as well as on right hand side, they are of same nature. So, the proof for this formula is also very trivial, and that is also the consequence of the formula which we have already discussed. All of you know cos of pi by 2 minus alpha is equal to sin alpha. So, by taking the advantage of this formula, what I have done, I have written sine of alpha minus beta is equal to cos of pi by 2 minus alpha minus beta. And I want to use the facts cos of pi by 2 minus alpha is cos alpha, sin pi by 2 minus alpha is cos alpha, etc. So, I am splitting this thing in this manner. This is cos of pi by 2 minus alpha plus beta. So, pi by 2 minus alpha you treat it as nu, let us say a, and beta as b. So, this is once again of the form cos of a plus b, and cos of a plus b, the very first formula which we derived was our cos a cos b minus sin a sin b. So, using that formula, what we get, sin of alpha minus beta is cos of pi by 2 minus alpha into cos beta minus sin pi by 2 minus alpha into sin beta. Again, taking the help of this remark which I have written with red letters, that is cos pi by 2 minus alpha is sin alpha, and similarly sin pi by 2 minus alpha is cos alpha. We finally get sin of alpha minus beta is equal to sin alpha cos beta minus cos alpha sin beta. Now, the same type of formula, let us see what we get for alpha plus beta. So, this is a very simple thing, this is the same formula which we have derived. Beta I am choosing as minus beta. So, alpha plus beta I can write as sin of alpha minus minus beta. Again I apply the formula for sin of alpha minus beta which I have given. So, this is sin alpha cos of minus beta minus cos alpha into sine of minus beta. But all of you know cos of minus beta is same thing as cos beta, but sine of minus beta is minus sine beta. So, using these two simple remarks, we get sine of alpha plus beta is equal to sine alpha cos beta plus cos alpha sine beta. So, these are the four formulas so far I have discussed, that is cos of alpha plus beta is cos alpha cos beta minus, so observe plus is on left hand side, minus is here, and things are like cos cos sin sin. In second formula, minus is on left hand side, while on the right hand side it is plus, and the nature is same cos cos sin sin. But in last two formulas, if plus is on left hand side, then plus is occurring on right hand side also. Similarly, corresponding to minus on left hand side, minus is occurring on the right hand side also. And of course, the slight nature is also changed. In first case it was cos cos sin sin, cos cos sin sin in second case. Here it is sin alpha cos beta, means sin cos cos sin. So, this is just the way to remember these formulas, they are very trivial. And here there is a remark, because I have proved basically cos of alpha plus beta is equal to cos alpha cos beta minus sin alpha sin beta, and with the help of this formula only I have derived rest of the formulas. But that does not mean that these are the only proofs. You could have started, you could have find out any value out of these four formula, and rest will turn out to be the consequences of that particular formula by simply manipulating the things, because cos theta is same thing as sin pi by 2 minus theta, and you can say cos pi minus pi by 2 minus theta is sin theta. So, you use any formula out of these four formula and try to get the remaining three formulas, and that you can do as a simple exercise. So, the proof of one I have given, but you could have started with the proof of any one out of these four formulas. So, this is the same thing which I have already mentioned. I have written them in a sort of diagram form. In a plus b minus b, the signatures, they are of the same nature. Look the left hand expression and right hand side expression, and in cosine case the signs are of opposite nature. That is, whenever plus is there, well, I am sorry, this is not plus minus, that is minus plus. So, excuse me, you can correct the thing, this is not plus minus, it is minus plus. Now, let us see what kind of application we can have using these four formulas. For example, you have to find out the value of sin 15. So, let us recall this formula, sin of a plus minus b is sin a cos b plus minus cos a sin b. Now, let me choose a is equal to 45 degree, b is equal to 30 degree. Now, the question is, why this 45 and 30 only? And answer to this is very simple, because all of you know the value of sin 45, cos 45, sin 30, cos 30, etc. So, we try to split out the value, like in this case it was 15 degree, in terms of the known angles. In this case, I have taken them to be 45 and 30. Okay, you could have taken 60 and 45, because their difference will also be 60 minus 45, the same as in this case. So, it is not any hard and fast rule, but the rule is that the angle A and B which you are choosing in the question, their sine and cosine must be available with you. So, I come back to there, that is sine 15 degree, I can write it sine 45 minus 30. Now, you use the formula sine of A minus B, and that is sine 45 cos 30 minus cos 45 sine 30. And all of you know your sine 45 is 1 upon root 2, cos 30 is square root 3 by 2, cos 45 is same as sine 45, that is 1 upon root 2, and sine 30 is half. So, after rationalizing them, just to make the denominator square root free, that is square root 2 into square root 3, that is square root 6 upon 4 minus square root 2 upon 4, that is same thing as square root 6 minus square root 2 upon 4. So, next example, find the exact value of cos 55 degree cos 10 degree minus sin 50 degree sin 10 degree. Now, if you have seen all those formula, if you are having all those sitting in your mind, then this is something cos A cos B minus sin A sin B. So, this will strike in your mind if you look at a glance the given problem. So, using that formula, that is cos of A cos B minus sin A sin B is cos of A plus B, and compare the given expression with this formula, then you can take A as 50 degree and B, while B as 10 degree. So, this is simply directly using the formula is cos of 50 degree plus 10 degree, which is cos of 60, and the value of cos 60 is well known. So, that is half. This is another kind of example, and if you look the expression sin 5 pi upon 12, then cos of pi upon 12 plus cos and sin. Again, once again you have to think whether you have to apply the sine formula or cosine formula. Then after this you have to think whether the formula will be of the nature sine of A plus B or cos of A plus B or sine of A minus B of cos of A minus B. So, as I gave you in the remark, it is something like sine cos cos sine with plus sine. So, you expect you are bound to apply the formula of sine of A plus B. So, I have given you the details also, sine A cos B plus cos A sin B, all of you know is now sine of A plus B. So, choosing A is equal to 5 pi by 2 and B is equal to pi by 12, we get that sine 5 pi by 12 cos pi by 12 plus cos 5 pi by 12 plus sine pi by 12 is equal to sine of their sum, that is 5 pi plus pi upon 12, and that is sine 6 pi upon 12, and that is sine of pi by 2, and the value of sine by pi 2 is well known, which is equal to 1. Now, let us find out the exact value of cos 75. So, as in the last example, here I choose A is equal to 45 degree and B is equal to 30 degree. So, there I was supposed to find out the value of 15 degree. So, I took 45 degree minus 30 degree. Now, instead of taking the minus sign, I am taking plus sign, and the corresponding formula plus sign will be changed, that will be of minus sign. So, I am using the formula cos of a plus b is equal to cos a cos b minus sin a sin b, where a is 45 degree, b is 30 degree. So, the value of the cos 75 degree is cos 45 degree into cos 30 degree minus sin 45 degree into sin 30 degree, and which is same as square root 6 minus square root 2 upon 4. Now, here is a simple remark, because this value square root 6 minus square root 2 upon 4, this you got probably in the case of sine of 15 degree. So, sine of 15 degree, by your using the formula that cos theta is sine 90 minus theta. So, your cos 75 degree has to be same as sine of 15 degree, which you are getting here also. So, without using this formula, you could have directly written this value, but there also you have to find out the value of sine 15 degree. So, either you find sine 15 degree or cos 75 degree, you have to work out in the same fashion. And similarly, let us see, we use the identity sign of a plus b to find the exact value of sine 75 degree. So, in this case now, once again I am writing as 75 degree as 30 degree plus 45 degree, and I will use the formula sine of a plus b is sine a cos b plus cos a sin b, with the choice of a as 30 degree and b is 45 degree respectively. Then sine of 75 is equal to sin 30 cos 45 plus cos 30 sin 45, and all these are standard values. So, I have written them 1 by 2 into root 2 by 2 plus root 3 by 2 into cos root 2 by 2, and this I can write as square root 2 plus square root 2 into square root 3. I can take square root 2 common. So, this turns out to be simply square root 2 into within bracket 1 plus root 3 divided by 4. Now, let us take one more example. Given that sin A is 1 by 3 and cos B is 4 by 5. Now, I have to choose here that A and B in which quadrant they are lying, because you have to be very careful. Apparently, this sine and cosine, they seem to be in your first quadrant, because in your first quadrant all these trigonometric values or trigonometric ratios, they are taking the positive values, but they may go in some other quadrant also, because in first quadrant all are positive, in second sine of some angle is positive, in third quadrant tangent is positive, and in fourth cosine is positive. So, in fourth quadrant cosine is positive as well as sin A is 1 by 3. So, in first quadrant sine is positive and cosine is positive. So, A and B I am choosing them to be acute angle, and in this case let us see how to find out the value of cos of a plus b. So, obviously, because you have to find the value of cos of a plus b, you have to use corresponding formula for a plus b, which is cos cos minus sin sin, that is cos of a plus b is cos a cos b minus sin a sin b.